Hi everyone, my name is Jean-Christophe. Today I'm going to teach you about linear regression in machine learning, and I'm going to give you a few examples of how that works. So linear regression is a supervised learning approach in which computer programs try to make prediction on continuous variables. To understand better, what it tries to do is it tries to find the best line to fit between a dependent and independent variable. And that concept of dependent and independent variable is not that complex, is you have something that has an impact on something else, and you want to predict based on those uh, independent variables. So you will see in the machine learning community a lot of terminology that are saying always the same thing. So essentially, you will have these names that come often. So we generally have the X variable in our Python code, or we call it independent or explanatory or predictor or feature, whereas the Y variable is the target, the dependent or the response variable. So essentially, X tried to predict Y. Um, Bear in mind, what a linear regression is it uses a straight line in order to compare the relationship between two variables. There are other types of regressions, such as a logistic regression, which uses a curved line to predict binary variables, for example. So to better understand this, I have this chart that brings you some of those concepts that you need to understand. So essentially, we have all these data points in blue, and what we want to do is predict a new data point that we don't know about by fitting a line on the data. And essentially, how we do this is that we have all these data points and we calculate the distance between the data point and the line in order to know how much error that we have. So the line tries to minimize the error. So you want all those data points to lie collectively all together to be as close as possible to the line that is possible to do it. So we start with an intercept that touches the y axis, and we have a slope that helps us calculate the slope of the line. And then we will look at the residuals, the green lines, um, in order to calculate the error. So linear regression is just one of the several regression models that you can use in machine learning. What you need to know is there are multiple types of linear regressions. You have the simple linear regression and the multiple linear regression. What this is generally when you only have one independent variable and one dependent variables, and you want to look at the relationships between those two, you will use a simple linear regression. When you have multiple predictor variables or multiple x variables and you want to predict them together, then you will need to use multiple linear regression. So the simple linear regression, what it does is uses the ordinary least square approach that we talk in another video. Uh, and it has that dependent and independent variable that we talked about. One thing to consider here is when you try to fit a line, you're trying to predict where the data point comes in. So you will use that simple linear regression when you want to identify how closely related two variables are. For example, if you try to predict ice cream sales based on temperature. And you will use that simple linear regression when you're trying to predict the value of that dependent variable when the independent variable changes. So essentially you will calculate the number of sales of ice cream at a given temperature. One thing to consider there is that you want to know the directionality of that relationship because, for example, can the number of cells of ice cream predict the temperature? Yes, possibly. And can the temperature predict the number of cells? Yes. But is it the ice cream that impacts the temperature, or is it the temperature that impacts the ice cream? So that's one thing that you want to consider. So now we are at that point where we look at the formula. So a little bit of maths here to understand what's going on. So the formula for the simple linear regression is y equal beta 0 plus beta x1 plus epsilon. And essentially we have this beta 0 is the intercept of the regression line, and then you want to have here the coefficient that impacts that quantify the level of impact of x on y, and you have epsilon, which represent the error margin, and you have y, what you're trying to predict. In your most basic math tutorial, you probably will have seen something like y equal ax plus b. So you have something that multiplies against x, plus you have your intercept here. So a represents the slopes of the line, x is the coordinate of the independent variable, and you have b, which is the intercept. So if we come back here, b would represent the star, and ax would represent that slope. So this is the most commonly seen expression of this that makes it more simple to understand. And we come back to that principle now that we know this, to how we calculate that linear regression line. Uh, One thing to understand is that it is one way. There must be an independent variable and a dependent variable, and there must be a single independent variable. So y must be dependent on x, but x cannot be dependent on y. So if we come back to that ice cream cone ideas that we discussed earlier, is that we could say that the sales of ice cream cone are influenced by the temperature, but saying that temperature will change whether or not I sell ice cream, that is a faulty assumption that you cannot do. So it doesn't work because Mother Nature is not dependent on Ben and Jerry's. Uh, and that's simple as that. Sometimes that line is a bit more blurry. When you have two or more independent variable, that's when we jump into that multiple linear regression I was talking earlier. So multiple linear regression is similar to what we just learned, but it's just has more independent variables that will contribute to the dependent variable. So you can have multiple features that will impact y. The formula is a little bit more complex, but essentially it is the same, but for each of the predictor, for each of the for each of the dependent variable, sorry, for each of the independent variable, you have you multiply a slope. So you will calculate the slope for each of the independent variable, and you still have one intercept, and you still have an error, and that's how you calculate. So in the next tutorial, what I'm going to teach you, now that we've covered those basics of what linear regression is, we will look how to make a linear regression in Python.